Okay, so we're going to go over simplifying and stating restrictions. This question here, this should be an equal sign here. We need to simplify and then state what our restrictions are. Pretty straightforward, but it's actually a difficult question. First off, do you know what type of equation these are on the bottom?
No. Standard?
You're right, they're in standard form. What are they considered in a graph? It's, what shape does it make?
U?
Parabola.
Yeah.
That's what they call it. Or it's a quadratic formula. That's what we're looking for, okay? So this is technically a linear formula. What this is some straight line. This is a linear one. It's a straight line. These create parabolas, okay? So what we want to do is think of these as their own little things, and we want to factor both of these quadratics, okay? So that we can see if we can simplify this question a little more, okay? So we're going to focus on factoring each of the bottoms. So we'll do the first one. Factoring. We take the factors of the first term, which is 1x squared, so 1x and 1x, and factors of the last term. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And we know that their products need to add up to what?
Negative
5x. So looking at it quickly, do you know which one it's going to be?
Is it gonna be...
While you do that, I'll write these factors.
3 and 8?
Yeah, that's right. It's going to be 3 and 8. Okay. So what you've discovered is that we know we'll have to multiply 1 by 3 and 1 by 8, which will give us 3x and 8x. One of them is going to need to be negative in order to make negative 5, right? Which will need to be negative?
8.
Yep, which means the 8 we multiplied will need to be negative. And let's make sure it makes sense. What's negative 8 times 3?
Negative 24.
Good. It is negative. So we know that that combination works. So when I go to simplify this, my next line here, actually would rather have page width. Good. Let's jump down. It's going to be is equal to x. Okay. And technically, okay, I'll write the answer at the bottom, then I'll write the simplified version. So this bottom simplifies into x minus 8 and x plus 3. Okay, that's our factored form. Okay, let's jump over to the other one, the green one here. How can we make positive 1x?
2 and 3.
That's right. We're going to use this column and this column. So we're going to get 2x and 3x. Okay, and one of them is going to have to be what?
Negative.
Which one?
3.
Sure. Negative 3 plus 2?
Negative 2.
Yeah, 2 have to be negative, right, to get a positive answer. So we're going to get x minus 2 is one and x plus 3 is the other. Okay, so same idea. Now when we go to write this, though, let's get our lines out. Let's go note to fraction. On this side, we're going to have x minus 8, x plus 3, subtract x over 1, and on the bottom, x minus 2, x plus 3. Okay, so this is a subtraction question of fractions. Okay, and in order to subtract fractions, what do we need to have?
Common denominators.
Common denominators. These are our denominators right now. All right, are they common? No, we have a difference. What is missing, or what's the same in each?
X minus 8 and x minus 2
Are what?
are different.
Different, right. We have an x minus 8 and we have an x minus 2. What about the other one?
It's fine.
And it's similar, right? So no, we know we're good. I'm putting colors to it because we're going to know we're going to need each of those colors on the bottom. Okay, so essentially in this one here we're missing x minus 8 or a blue color. And in this one here we're missing x minus 2 or a green color. Okay, so we're going to multiply the entire fraction, each of them, by what they're missing. Okay, so what that means is our fraction on the left, I'm going to be multiplying the top and the bottom of the fraction by x minus 2, right? Because that's what's missing for our common denominator. And let's make it a blue color. Over here, we're going to be multiplying the top and the bottom by x minus 8 so that we have a common denominator. Now, on the bottoms, we're not going to expand or anything like that. We want the bottoms to be the exact same. Put our lines in here. So now that we've multiplied through, we are just going to write it as x minus 8, x plus 3, x minus 2. Nice and easy, subtraction sign. And we'll write it in the same order on this side. Okay, even though it looked like it was in a different order above, it's fine. Doesn't matter what order we multiply things are in. Is that okay so far? Mm-hmm. So we have common denominators. But on top, I now have x and times x minus 2. And over here, we have x minus 1 times x minus 8. Well, all of this can be written as one line now because we have common denominators, just like when we're adding our subtraction fractions. So now everything is over x minus 8, x plus 3, x minus 2. Everything's over that. And we're going to bring that subtraction above, and we're going to have x minus 2 subtract x minus 1, x minus 8. Okay. So our new goal now is to expand and simplify the top of this. We're just going to focus on this part here. Okay. We're going to expand and simplify, try to get a quadratic, and then factor that to see if we can simplify farther. That's our new goal. So we'll do it in, we didn't use blue before, right? So we're going to do that in blue. So x times x minus 2 is x squared minus 2x. All right. Technically, there's a negative sign. Let's FOIL this before we go anywhere. That's going to give us x squared minus 8x minus x plus 8. Does that make sense so far? Mm-hmm. Okay. I'm going to keep going. I'm not going to write the bottom for now. We'll put it in after. I then have to distribute the negative to every single term. So we have x squared minus 2x minus x squared. Now, let's equate this. Negative 8x minus x is what?
Is it negative 7x?
Other way.
Negative 9x?
Yeah. But because we're multiplying by a negative, it now becomes
plus 9.
Plus 9x. And because there's positive 8 times a negative, negative 8. Does that make sense? Mm-hmm. Now we're going to collect our like terms. So we have some like terms here and here. So we're going to combine them and see what we can do. Well, x squared minus x squared creates a 0. 9x minus 2x gives us 7x. Let's keep it in blue. I don't know why I chose black there. 7x and minus 8. So that's what our new top's going to be. Yeah. We just simplified it. So we jump down again. We got 7x minus 8 above x plus 8.
It's minus.
Oh, was it? Thank you. Good memory. X plus 3, right? Yeah. And then x minus 2. And that is as far as we can go.
Oh.
Okay.
Simplify and state restrictions.
Oh, state restrictions. Thank you. I forgot what we had to do. So we've now simplified. Mm-hmm. Okay. But at the very beginning, we've got to jump back to our beginning and figure out what our restrictions are going to be. So let's jump way back up here. Restrictions are numbers we can't have. And what happens here is the bottom of this equation here, we cannot have any of these become 0. Because if any of these become 0, when we multiply by 0, we'll have a 0 on the bottom, which is undefined. We can't divide by the number 0. So what we're going to do is, luckily in this question, it's just these 3, right? There's no extra ones that we actually cut out of the question at the end. So it's the same 3 that we have at the bottom. Now, normally you need to do this at the very beginning. Because we didn't actually cross any of these out, we can use the 3 at the end. But had I crossed out, say, negative 8 in some type of, maybe this was on top, we crossed that out, this negative 8 still would have had to be included in the restrictions. Does that ring a bell to you? Make sense? Okay. So let's write our restrictions here. We set each of these equal to 0. It's pretty easy to tell what they're going to be. Do you know what the x cannot equal?
8.
Yep.
Negative 3, negative 2.
That's right. And those will be our restrictions for this question.